This video is how to do the Johnson transformation in Quantum Excel. As a setup, I have the data for 30 different parts that the flatness was measured in cells A1 through A31. I could select this data with my mouse like this, just select the full range from A1 to A31. However, because the only data that is in that column is flatness, I can also just click on the A column and Quantum Excel will do the entire column. Then I click on Stat Tools, Analysis Tools, Johnson Transformation. Quantum Excel asks me the data range. Since I've pre-selected the data, I don't need to do anything. However, if I had forgotten, then I can select the data now. There are no options for the Johnson transformation, so there is no next button. I simply click on Finish. Quantum Excel then calculates the optimal Johnson transformation for me. The transformation details are listed on the left-hand side. However, the actual transformation is on the right-hand side. So this column says original data. The first entry is 4.15. That 4.15 was from the original data set. So if I go back over to the flatness tab, we can see that 4.15 was the first data point. The original data was 4.15. When I take 4.15 and I transform it using this transformation, the resulting value I get is 1.966. Quantum Excel transforms all of the data, so all 30 of my data points have their transformed values. However, if I want to transform any other value, such as a spec limit, then this portion right here of Quantum Excel, it transforms a number. So for example, the default value is the first data point in the data set, and it's 4.15, and we can see that 4.15 transforms into 1.966. To demonstrate how that works, I'm just going to type in 1.05, which is the second number in our data set, and we can see that 1.05 transforms into negative 0.93. Below that is the inverse transformation formula. So the inverse transformation formula takes a transformed value and puts it back in its natural value. As an illustration of that, I'm going to take this negative 0.93 and then I'm going to type it in here for the transformed value. And you can see that the result is that it transforms it back to its original data of 1.05. Below is some very technical details about how the transformation went. There's a list of all the z-values that were tried to find the best transformational fit. Then there's the probability plot for the original data, key point being the original data. We can see that the Anderson-Darling p-value is well below 0.05. It's 0.005, indicating that we're greater than 95% confident that the data does not follow a normal distribution. Below that is the probability plot for the transformed data, keywords being transformed data. We can see the Anderson-Darling p-value for the transformed data is 0.9445, which is much better than the original data set. And that is how you perform a Johnson transformation in Quantum Excel.